Hello everyone, my name is Ana Sainz, PhD student in the University of La Rioja, in Spain. This is the second video of my virtual mobility grant. In this case, I will give you a global information about how some PlAgri members are working in terms of biological decontamination and chemical decomposition. First of all, I sent to the COS members a survey with different questions related to their plasma systems, the purposes, or the characteristics of the plasma treatments. I also wanted to know if they are using one plasma system for more than one objective. And finally, the challenges, the scalability, and the availability to collaborate with other groups. In this slide, we can see how many people received the survey. In this case, more than 100. And 17 research groups sent back the survey. Moreover, we can see the countries participating, and Italy and Spain are among the winners. Let's start with the plasma systems used. In this graph, we can see that the jet is the most common one, followed by the DVD. Moreover, the vast majority apply plasma at atmospheric pressure, and none of them apply treatments at high pressure. This slide shows the objectives of each group. They are divided into planktonic bacteria inactivation, biofilm bacteria inactivation, chemical decomposition, and some mix of them. Thereby, the winners are chemical decomposition and biofilm inactivation, chemical decomposition, and planktonic and biofilm inactivation. It is worth mentioning that there is no group that only studied biofilm inactivation. Besides, in the other part of the slide, there are some examples of the most common bacteria and chemicals used, such as Salmonella, E. coli, or different dyes. Let's move to the plasma treatment parameters. In the next slides, there are different values for each parameter, depending on the final purpose. For instance, for planktonic bacteria inactivation, the power is between 0.5 and 500. Then the gas flow could be at open air or from 0.03 to 80 standard liters per minute. Related to the type of water, the ionized is the most used, but some researchers also work with tap water or liquid food. Finally, air is the winner gas, but there are other ones such as nitrogen or oxygen. Here we can see the parameters in order to attack biofilm bacteria. In comparison to planktonic treatments, the power and the frequency of these ones are higher due to the resistance of biofilms. The type of water is the same than in the last slide, and in this case, despite of being there the most common gas, combination of gases like oxygen or argon are commonly used. Finally, for chemical decomposition, the parameters are those ones. In this case, only the ionized and tap water are used, and air, helium, and nitrogen are the most extended gases. Last but not least, I would like to talk about the water volumes. It is known that even though one group works with 20 liters, the volumes are not large. This is a disadvantage in terms of scaling up to the industry what is found in the lab. This is in line with the next slide. After asking about scalability, the majority of the people answered positive. In other words, they said that the procedure and the experiments they perform could be applicable to the industry. However, most of the groups say that on paper, and these are some ideas to achieve that purpose. But they are not doing the scale-up right now. So, should we think more about that issue and how to do it? Other vital question was the next one. In case you have more than one purpose, are you using the same plasma system? And the majority of the members explained they use only one plasma system for each purpose. Nevertheless, for two objectives, people try to change the parameters or even add tools printing 3D pieces. At that point, is it better to use only one plasma system? Yes, in terms of reducing costs, or increasing space in the lab. It's also worth mentioning the importance of this fact when trying to scale up. Now, I will show you a great example of how one plasma system can be used for two different purposes. The first one is chemical decomposition. By these images, the plasma system is explained, and there is also a video. The second one is biological decontamination. Again, there are really good images showing the treatment and a video. Now, in this video, we will see how it's possible to change the tools for chemical decomposition to the ones used for bacteria inactivation. The survey also asked for the difficulties found during the plasma treatment, and here we can see some of them for chemical decomposition. This slide has the same format than the last one, and it's related to the challenges found when treating plasma-activated water for biological inactivation. The last question was about the willingness to cooperate. The answer was yes in almost all the cases, and these are some of the issues the groups are looking for. Finally, I am open to create new networks among research groups. Then, if you have some of this equipment and you would like to help other groups, just send me a message and I will put in contact the research groups. To finish, if you have some questions about how to modify your plasma system, don't hesitate to contact me. Thank you for watching this video.